I'm not necessarily a star, but I'll try to be. All right, so let me just close a couple windows here so they don't start popping up when we are presenting. So just a quick feedback. You were now looking to my slides, right?
Yeah, we see.
And this is my ID.
Yep.
So for everybody that's watching us, there will be instance in this presentation, I'll show some code. So let me know if this font size is fine, or perhaps this is a bit better.
Yeah, it could be a bit better. This one is okay. I will let you know if it will be too small, okay?
Okay, all right.
And also if, I mean, any of our attenders have any problems, let us know on the chat. We'll let Ricardo to change anything. Okay, thank you.
Yeah, all good. Thanks.
All right, thank you very much. All right, so let's get started. We have some ground to cover today, and but first of all, I would like to thank you, both Tomas and the DataOps community organizers, for this opportunity. I mean, like Tomas said, we met on 2019, and for me it was a special occasion because not only it was my first time on Warsaw, but also I like the guys there. Like the people were very friendly, and I think the community that you were building there are pretty awesome. So congratulations by itself, right, for the success of the community. So this presentation is going to be about Elasticsearch, obviously, right? It is in the title, but I think that what I'm trying to achieve here today is to share some of the features or perhaps some of the characteristics of Elasticsearch that are interesting, right? But they sometimes are kind of an oversight, like people don't pay attention too much, or perhaps sometimes they don't know even that feature or functionality exists. So I'm going to walk you through and what I think is interesting. This is not supposed to be an exhaustive list of features or hidden functionalities, right? I'm going to actually take Tomas' advice, and then in case you feel that there might be some other features that you would like to cover, we can schedule the next meeting for this. So that it will be my pleasure doing this, right? So a little bit about me. For those of you that don't know me, my name is Ricardo Ferreira, or just Ricardo. Feel free to just call me Ricardo, it's fine. Currently, I work as a developer advocate at Elastic. That is basically the company that is behind Elasticstack, right? You probably know what the Elasticstack is. We're Elasticsearch, Analyze, Stash, and Beats, right? So in Elastic, I'm part of the community team. So basically what I do is developer advocacy, right? Before Elastic, I used to work for Confluent. That's where I met Tomas in 2019. We were organizing this meetup about Kafka and data streaming technologies. And then we kind of exchanged a little bit about the Kafka word. And while I am still involved with those communities, Kafka, Pulsar, and some other streaming technologies, but obviously my main focus today is the technologies from Elastic, right? But I like to say that I'm not limited to only what Elastic provides. So if any of you have any questions, or maybe you would like to discuss something related to the big data, streaming data world, I am always available to it, right? That's why I brought here my contacts. This is my email from Elastic, or you can just send me on my personal email. That's the second one over here. My Twitter here on the bottom. My DMs are free, so feel free to get in touch, and I will be more than glad to help with anything you need, right? So without further ado, before jumping to the features per se, or actually before that, quick disclaimer, the way I like to do presentations, I usually don't have like a Q&A session in the end, right? I would rather for you to ask your questions as I am presenting, right? So I have here, I'm looking to the chat window right now. So I will keep looking at, and Tomas, if you can also help me if there's some new question pops up, I will be more than glad to stop what I'm saying, address the questions, and then we can resume, right? I prefer doing this because Q&A in the end usually kind of lose a little bit of the context for the questions, and I like to make your questions as contextful as possible, right? So just a quick disclaimer, feel free to ask. If you don't have anything to ask, that's okay as well, right? But anyway, so before jumping into the features from Elasticsearch, right? I would like to take a pause here for us to reflect a little bit about what Elasticsearch actually means, right? I think this is important because the features that I've brought you today, we're going to talk about some of them that are not so trivial, right? So that's a given. And some of them will be not constantly used in the universe of the Elasticsearch as people know it, right? For example, what I'm trying to say is that if you use Elasticsearch for pure log aggregation, which is a very amazing use case, right? But if you use it only for this, there will be some features that perhaps you don't need it, right? But perhaps because you are using only for log aggregation, you never had the chance to actually be aware that the feature exists. So I think this exercise is going to be interesting because you, and this is my intention, right? You're going to uncover what you don't know, right? So, and this is often a very good exercise. For example, when I was working for Confluent, from time to time, I would step one back down, and then, all right, I would forget that I had a bit of experience with Kafka, and then I would talk to engineers and read some pieces of the documentation, and I would often find out that, all right, I never saw that this feature was here in the first place. So, and it's pretty awesome. So let me try to understand the feature and try to use it in my work database. So this is exactly the exercise that I did with Elasticsearch as well. When I joined Elastic 6 months ago, I had a vision about what Elasticsearch was, right? And I knew that it has to do with analytics, right? It is a data analytics platform in the end of the day, but I didn't know, and I had no idea about how comprehensive the data analytics implementation for Elasticsearch would be, right? And this is something that I would like to discuss right here, right now. So in order for us to be on the same page, the features that we are going to discuss here today is going to show kind of a new Elasticsearch, right? What I mean by new Elasticsearch is this. Everybody knows that Elasticsearch is an extremely accomplished distributed data store that is used primarily for this, right? Full text searching, right? And it is amazing, right? It is arguably the best technology for you to implement use cases where your searches are not necessarily well defined. By the time you are modeling your data, you are modeling your schemas, right? So even if you have no idea about how your searches are going to look like, right? Elasticsearch offers you the capabilities to perform searches in a way that you don't necessarily predict it in the first hand, right? So this is one of the most amazing things Elasticsearch does. So that's why I joke here in the title. So Elasticsearch is more than, for search. So for those of you that know Elasticsearch, you know what the joke is about, right? For search is kind of the description that when you issue a request to the cluster, you're going to receive a JSON payload in response that basically contains the string saying, for search. So that's where the jokes came from. However, let's take one step back and then let's forget for a moment that yes, Elasticsearch is extremely good for full text searching, but what Elasticsearch is as well, right? What can be used beyond full text searching, right? So the first characteristic is it is a NoSQL distributed database, right? So by being a NoSQL distributed database, it allows you obviously to store data, right? It cannot be like any type of data. For those of you that know Elasticsearch, everything in Elasticsearch is based on JSON, right? So it is by far not a type of databases where you're going to store, for example, binary objects, right? Just like you would do with Kafka, for example. Kafka, you can store array of bytes because it has a opaque format. Actually, it's formatless, right? It doesn't have a format. In Elasticsearch, in order for you to have minimally a description of your metadata, the documents needs to be in the JSON format, right? So that's a given, right? But beyond that, it is a complete NoSQL database. You can have You can have operations that you would do and execute with another NoSQL databases, such as Cassandra or MongoDB or DynamoDB. So it is certainly a database that you could explore if your use case is not necessarily about full text search, right? So this is a given. Secondly, Elasticsearch is extremely good if you have use cases that handle time series data, right? So what I mean by time series data, it is any type of data that it might have a unique identifier, right? Social security number if it's a person, or perhaps is a generated ID if it's a IoT sensor reading or something like that. But more importantly than those identifiers, known identifiers that we used to have, each document has a timestamp, right? And each document might be different from each other. Not the whole data could be the same, right? But the timestamp will always be different, right? You can have two documents stored on Elasticsearch that basically their difference is because one of them has been collected and stored 1 millisecond ago, right? But the payload itself is the same, right? So this is what time series data is about, right? And there's a bunch of use cases in the market about time series. For example, Elastic itself created a whole observability solution on top of Elasticsearch to collect metrics or traces or logs. And all of this is stored in Elasticsearch and fulfills what you can see on Kibana as the observability platform, right? But in Kibana, you're basically seeing what is stored in Elasticsearch. So therefore, the actual magic is being handled by Elasticsearch, right? Because Elasticsearch is able to handle data that is time series, right? This is important because I have heard some misconception in the market that says, all right, no, Elasticsearch doesn't handle well time series. It's only for full text search. And this is not true, right? And the proof of this is that we have different solutions written on top of Elasticsearch exactly for doing this, right? Name it, observability or CM, security, and any other solutions, right? So that's the whole point. And this was kind of also a, wow, I didn't know this. When I firstly joined Elastic, they were announcing back then some features that, because I came from the streaming world, right? I came from the Kafka world. I came from the AWS Kinesis streaming world. I came from the messaging world, right? Because I came from this world, I was able to spot those features and say, okay, all right, this is kind of similar to what we used to have there in Kafka, for example, but it's interesting because I could use those features to implement somehow the same thing, right? Obviously, I'm not saying that, oh yeah, you're trying to say that Elasticsearch could be a full-time replacement for Kafka. No way at all, right? Kafka still has its value. It has the specific use cases where Kafka does best, and Elasticsearch would suck, right? But what I'm trying to say is that some of the characteristics that you find on Kafka, you can do in Elasticsearch. And this is important because sometimes, and this is the tricky part, right? As developers, as technologists, sometimes we adopt new technologies, or perhaps let's call it new complications, right, in our world, just because we are interested in one specific set of features, right? I'm going to talk about this later because one of the features that I'm going to discuss here today, it has to do with streaming, right? But I think that's interesting because if you have a use case, if you have a Elasticsearch or Elastic Stack deployment in place already for your applications, right? And you were considered, for example, oh, I'm going to bring Kafka and Kafka Connect and KSQLDB here just because I want to do this, and that, maybe you can actually do not bother to bring Kafka to the world and resolve that problem with Elasticsearch, right? Again, and I'm going to exhaust this. This is not the same to say that Elasticsearch is a full-fledged replacement for Kafka as a streaming platform. Elasticsearch was not built to this, but there are some characteristics that you can do with Elasticsearch, right? So let's recap. You can use Elasticsearch as a NoSQL distributed data store, right? You can use Elasticsearch as a database for time series data, and you can use Elasticsearch for handling some of the streaming scenarios that are rapidly popping up in the industry these days, right? The use cases that has to do with handling data streams and analyzing data as they come and providing feedback and insight with some output strategies, right? So that's basically what a stream is about. And yes, of course, you can always use Elasticsearch for what it does best, which is being a full text search database, right? So before I continue, I'm going to actually pause for a second and check if anybody has a question. You can fire away in the chat if you want it.
So no question at this moment, just a reminder, you have raise the hand button. So if you need anything, just push it, okay?
All right. Oh, actually, there's one here from Radu. There is a debate online whether Elasticsearch should be used as a main database or not, if it's safe to store production data. I'm not sure if I've seen this specifically debate, Radu, but I definitely saw some other debates about the same topic, right? Which is whether Elasticsearch can be used as a full-fledged replacement for database. And I have an opinion about this. I can share with you, right? But obviously, at Elastic we have this kind of it's part of our culture that for every situation, I think the correct answer should always start with "it depends," right? Because pretty much in life, it depends, right? You have to analyze different perspectives and different contexts. But in my opinion, right, I like to say that depending what it all boils down for what you were looking for in a database, right? I like to explain that databases are like onions, right? If you take onion and you start to peeling off the onions, you're gonna separate the layers, right? That are basically the characteristics of a given database. But when you find a core, what fundamentally a database does, it stores data, right? Reliably and durably, right? So if you ask me, Ricardo, do you think Elasticsearch stores data reliably and durably? Yes. Elasticsearch has all the characteristics to ensure the ACID word from database word, atomicity, consistency, isolation, and the last one is durability. The D letter is there. I can assure you that, all right? There's not much about consistency, the letter C, right? So as you may know, because Elasticsearch is a NoSQL distributed data store, it provides eventual consistency, right? So what that means is that if you are trying to use Elasticsearch for a use case that requires you an extremely strong consistency level, right? Just like you would find for SQL databases, for example, I don't think that's going to be a good idea, right? So, but as you can see here, we're putting ourselves away from what is core, which is store data durably and reliably. Now we're talking about another perspective, which is consistency, right? So consistency is not much transactions as an example, right? Elasticsearch doesn't support the concept of transaction, and according to Shay Bannon, which is the creator of Elasticsearch and also the CEO of Elastic, it will never support, right? This was done on Elasticsearch intentionally and by design, right? Which is good and bad, right? It's bad because if your use case requires transactions, so Elasticsearch won't fit. But for use cases such as time series data, streaming, or full text searching, it works fine, right? You don't necessarily have to use transactions. So I think consistency is what's going to be the Achilles foot of the problem. It has atomicity, right? If you think about it. And also it supports isolation, right? So in terms of transaction, I think the only letter from the ACID is going to be the C one. Elasticsearch is not very good for this, right? But again, let's put the conversation in another way. Let's say I'm creating an application that doesn't have strong consistency requirements, but I still need durability, I still need elasticity, I still need reliability. Yes, Elasticsearch is an amazing database, right? The other aspects that you should also evaluate is, right, forget about your view, your perspective of a data ops or a data guy or a data person, right? Guy is not a very good term. Let's use the term person, right? It's not very inclusive. So imagine that you are a person that is not necessarily tied to the data ops or the data world, but you are a developer, right? That's important. As a developer, you have to have in a database all the characteristics that are going to make your life easier. So I'm going to give you a very concrete example. If you are, any programming language these days supports JSON, right? Which is basically the format that you have to use and create in your applications in order to interact with Elasticsearch, right? So good so far. But what if you were writing an application and you were writing this application in Golang, for example, right? It can be another, but let's take Golang as an example. And as you may know, Golang has this own serialization framework and serialization strategy that is highly based on a technology called protobuf, right? Which basically grabs objects and structs in memory and serialize them into a binary format. And that binary format can be either replicated across the network or can be stored into a database, for example, right? But again, the format itself is binary. So if you have this situation, for example, no, Elasticsearch will be a terrible fit for your use case. Why? Because it only supports JSON, right? So in order for you to actually work with Elasticsearch in this situation, you would have to, okay, from time to time, I serialize protobuf from one side to another, but by the time I have to interact with the Elasticsearch, I would have to serialize from protobuf to JSON and vice versa, which can be a little bit about time and CPU consuming, right? So those are there's a bunch of other factors that we could discuss here, but I would say that primarily there's not an easy answer for this. All right, Elasticsearch can be a de facto replacement as a database. It depends, right? Are you serializing your data in JSON? Do you have strong consistency requirements in your application? So you have to kind of I don't think there is a correct answer for this. Not sure if that helps, Radu. Let me know if this kind of helps. We can discuss a specific perspective if you want it, but I think that's basically what it is, right? We can go much from there.
Okay, no more questions until the Q&A session because it's second slide and we have half an hour.
Yeah, that's true. That's
forward,
true.
okay.
All right, so let's talk about some interesting features, right? For pretty much all of them, I would try to show you an example. I actually brought an application with me today, right? That I'm going to intentionally deploy from scratch because I want you to see the behind the scenes of it, right? So let's start. Oh, before this, there's only a quick disclaimer that some of the features we're going to talk, some of them might be a little old, but some of them might be new. So I'm going to mix and match these features, right? All right, the first one is the Terraform provider, right? So I think the first question that I had to ask here is, how many of you know Terraform, right? But otherwise, it's going to be kind of a pointless to explain this feature. But let me give you an overview. Terraform is a infrastructure as code technology, right? So what that means is that you can program your way out to deploy a complete infrastructure as well as all the services on top of this infrastructure using a code, right? So basically you program instead of tweaking and like turning knobs manually for every single time you're going to deploy an application. It's amazing, right? So I think Elastic created it has been available a while ago. It's not completely GA, right? So there's that. It's changing a little bit, but it will be GA this year. But what is important is that you can use the Terraform provider for Elastic Cloud, right? If you are using Elastic Cloud, the managed server from Elastic, but also if you are using what we call ECE, which is you can create your own Elastic Cloud on-prem, right? And you can spin up new containers, you can spin up new Kibanas and Elasticsearch. But by the time you can have the support for the Terraform provider, you can do all of this programmatically, which is pretty awesome, right? Personally, the value that I see in the Terraform provider is because you can actually mix and match details of the application with the details of the infrastructure. So what I brought here for you today, I'm actually going to grab the link from this GitHub repo. So if you want to play with this later after this presentation, feel free to. But this is basically going to be the game Pacman. Tomas probably might remember that I've ran this demo when we met in 2019. But what I did here was to recreate that demo. Instead of using Kafka, I've recreated completely to use and run on top of Elasticsearch, right? So in order for you to deploy this game in a cloud provider, you run Terraform, right? So that's what I'm going to do now. So let's switch for the IDE here. I'm going to show real quick the Terraform code. I'm going to deploy on Google Cloud for this demo. So let me open here this elastic.tf. Everything in Terraform is a t.tf file, right? So that's how Terraform organizes the code. So pretty much what you do in the provider, for example, in Elastic Cloud, right? We have this concept of deployments, right? For example, I have here an Elastic Stack that is called as a deployment. So when you write this here, you are specifying that you are going to create a deployment called Elasticsearch, right? And then you can specify some details about what region. In my case, specifically, I need to set some course. It will be the equivalent for you to go manually in the /config folder of your Elasticsearch installation and editing your Elasticsearch YAML file and put this information right here. So you can declarative specify this, right? So for us to not actually waste any time, I'm going to run the script that will execute all this code. But what this code does, other than creating the deployment on Elastic Cloud, is also there will be the Pacman, for example. All the code is a JavaScript HTML, right? So basically what this code is going to do is going to also, along with the Elastic Cloud, is going to create a bucket, right, on Elastic Cloud, on Google Cloud, sorry. And we'll start deploying the HTML files, the JavaScript files. And the beauty of the Terraform is that you can execute all of this atomically, right? What atomically here means, if for some reason the deployment of the Elastic Cloud deployment fails, the whole remaining of the code is not executed, right? So you have immutable atomic deployments, right? So that's the beauty that you can use Terraform along with your Elasticsearch clusters, right? So in this situation right here, as you can see here, the cluster is being created. So if we go back to Elastic Cloud, we should have a new deployment coming in. Let's see here. So it's being deployed, right? It takes roughly 4 to 5 minutes to deploy. So Terraform keeps monitoring, right, when it finishes or not, right? So that's what's going to happen, right? So while it's deploying here, right? So let me show another one. Okay. And the other one is going to be the future of data streams, right? Not sure how many of you have heard about data streams before, but data streams, for those of you that know Elasticsearch, can be seen as a pure index, right? But think about this. Perhaps you have an index, right? And it's filling up very quickly, right? And the best practice to make sure you're gonna sustain some performance requirements is to maybe create another index. Maybe you're separating your indexes by week or by day. You have some time criteria for this. And then you would manually migrate some of the data from one index to another, freeze this one, and then all the new data is going to be written in the new index, right? But again, you had to manually create a new index based on some criteria, and you have to keep refreezing, reindexing, all of this, issuing manually requests to Elasticsearch, right? So data stream is a feature that you can use to automate everything that I've just described, right? So you have conceptually from the perspective of the application, it thinks that is writing into a index, right? So behind the scenes, what is happening is that Elasticsearch is creating what we call backing indexes, right? So for example, the green ones are the ones that are already frozen. So they fill some criteria and they kind of created a new one, right? So the new data is always appended to the active backend index, right? If you think about it, right, for those of you that know Kafka, this is the exact same mechanism that Kafka uses for organizing the data into the log, right? So what Kafka does is the log, your topic is broken down into partitions, and each partition behind the scenes is broken down into segments, right? So those segments, there is the active segments and the offline segments. So this is exactly what Elasticsearch is doing here. But for you, it's transparent, right, which is pretty cool. All right, your code doesn't need to change. The only thing you have to change is how do you create the index in the first place, right? Which is not simply create an index. Let me check. The cluster seems to be okay. The deployment is fine, right? I'm going to open Kibana here so we can play a little bit of some of the things that I'm going to show you. I will log into this Elasticsearch. This is the password. Elastic. What's being shown here on green is what we call output. So I created this output here in TERRAFORM. So basically, when everything is created, it's going to run the outputs. And this is what is being shown right there. So Kibana is basically grabbing the deployment and showing the HTTPS endpoint and blah, blah, blah. So you have full control about all the things that entails your cluster creation using the TERRAFORM provider. So I would recommend for you to take a look in this provider because TERRAFORM is one of those technologies, just like containers. You might be a bit skeptical at first to use it, but when you start using and you see the value of it, you don't think yourself in using something else, right? For me specifically, I only deploy my applications and demos and proof of concepts using TERRAFORM because I can spin it up, work what I need to do, and programmatically destroy. And this destroy is consistent, right? It basically destroys everything in the reverse order it was created. So it's pretty amazing. Okay, so this is a brand new Kibana, right? So there's basically nothing here other than the artifacts that was created. So back to the data stream that I was mentioned before, if we go to stack management, you're gonna see here, if you click here on index management, you're gonna see that I have two indexes, right? One of them is called Pacman scoreboard, right? Doesn't matter what this is right now. It's part of the game. Okay, I'm gonna show you in a minute. But if you click here on data streams, you're gonna see that, all right, there's this one called Pacman input data, right? So long story short, all the data coming from the game will end up here on this data stream, all right? And then there will be some processing done behind the scenes that will basically, the result of this processing will be written here into this scoreboard index, right? But again, the scoreboard is a regular index, the same one that you used to create, and the input data is a data stream, right? So what is the main difference? What the application knows is this. And the application thinks that is writing and reading from an index. But in reality, what is happening is this. If I click here on this include hidden indices, you're going to see that a bunch of hidden indices will be shown. And one of them will be this one right here. So not sure if you can see here. It says DS, which stands for data stream, and then Pacman input data. This is the actual active index at the moment, right? So basically the criteria here, what's going to happen is that with time, a bunch of other backend indices will be created that will hold the current data, or anything before will be still available for reading, right? But writing is only on the active data. So pretty much how a distributed log store such as Kafka or Pulsar organizes time series data. This is important. Data streams are very good, but it only works if you work with time streams, right? Sorry, time series data. So let me show real quick here the face of a data stream. Input data, right, data stream policy. No, it's not a data stream policy, it's input data template. Yes, that's the template. All right, so basically this is a data stream, right? So as you can see here, this is the code that I've used, a template that I use it to deploy that data stream. So basically, as you can see here, you can specify one or more index patterns that will group together all the backend indices based on some name strategy. And then you have to specify this word here, data stream, right? There's some configurations that you could put here. I just used the vanilla one. And then just like other indexes, you can use some settings for the template. And of course, you can predefine, you should actually predefine your mappings, which is your scheme. So pretty much this creates a data stream on Elasticsearch, all right? Okay, so for me to actually continue with the next one, right, which is transform, I actually gonna need your help, right? I need you to play the game at least for a minute, right? So if you could, please, I'm going to give you the URL of the game, right? I am going to copy here and put on the chat, okay? And basically all you have to do is to click on that link. I assure you there's no virus, so go ahead. And you're gonna put your name, okay? And then you're gonna start playing Pacman, right? As you play, I can kind of monitor from here who is playing because there will be a dynamic scoreboard. I'm gonna put my name here. I'm not going to play, I'm just going to open the scoreboard. All right. Okay, I'm just want to, so yeah, so there's some people already playing. Rafael, Tomas, Benas, Dimitri, Radu, me. I'm not playing, but I'm being shown here. So not sure if you're playing, but if you look to my screen, right, you're going to see that this scoreboard is alive. Right? So what I mean by alive is that it's showing dynamic data, right? So, so yeah, play a little bit. I'm gonna give you a minute and then I can show you the magic that's happening behind the scenes, all right? So only for you to know, this is a web application, right? And it's written on HTML and JavaScript. So basically what this web application is doing right now is there is a web puller, right? Which is basically a background thread that executes behind the scenes, that each execution doesn't necessarily force a page refresh, right? I'm not a web developer per se, but not sure if this definition sounds okay, but this is basically what it's doing right here. So, and each pull is basically querying the current state of the scoreboard index, right? So basically this is what this web application is doing. That's what's kind of making this feel of, okay, it sounds dynamic, but in reality, there's a puller that, okay, give me the new state. Give me the new state. So that's what it's doing right now. Okay, so you can continue to play, or you can just pay attention to what I'm going to show you here. Let me explain, right, what's happened behind the scenes, right? So as I mentioned before, what the scoreboard page here is from time to time is refreshing and querying the state of the of this scoreboard Elastic Community Index, right? And as you can see here, look at this. It's currently have 14 documents on this in this index. And if you think about it, this is exactly because there are 14 players. So 14 entries on that index, right? So what that means is this. If you look to the data stream, right? Now let's take a look on the data stream. So let me show the hidden fields. And if you look here, the backing index, you see here that it is 3,715 documents already on the input data stream, right? So what is happening? There is something called transforms. There is, every time a new document arrives in the data stream, it will compute this new document and flush the results into the scoreboard. So input, processing, output, right? Pretty much what all of us folks from the DataOps team, right, do every single day, right? Input, processing, output, right? And transforms is the feature that I was mentioned before. So basically what transforms does, it grabs data from a source index and then processes and put the data into a destination index. So let me show you the transform here real quick. I'm gonna click here on transform. And as you can see here, I have a transform that is also called Pacman scoreboard. There's two modes you can create and execute a transform. You can create a transform, but execute in a batch, right? The name says everything. From time to time, it will wake up, execute, and sleep over again, right? The one that I've created here is called continuous transform, right? What means is that it continuously keep processing as new data arrives, right? So what's gonna happen is this. Let me expand this here. If I click here on preview, you're gonna see that all the data that is currently being shown there as well on the scoreboard, right? So if you look at here, it's going to be the same data, right? And basically what this, let me show the code of this transform. Here we go. Basically what this transform is doing is I'm using the pivot right here to aggregate and group all the data. I'm grouping by user, but what are the aggregations that I'm running? I'm running a max on the field game score. I'm running a max on the field game level, and I'm running a sum on the game losses, right? And I'm basically, my source is my input data, which now you know that's not an index, it is a data stream, right? So one of the most amazing things about transform, right? Obviously, you could do this using Logstash. You could do this like using some ingest node pipeline for Elasticsearch, if you know the other options, right? There's nothing wrong in using those approaches. But what is interesting about transforms is the reliability of the process, right? Why? First of all, right, there is a reason why every time you create a transform, you are going to specify a timestamp field and a timestamp delay, right? What happened is that when you deploy the transform, Elasticsearch will distribute all the processing across the cluster, right? Which entails that more nodes you put on the cluster, more processing power you're going to have, right? If you happen to have bottlenecks. But what is important is that each execution of the transform is stored on the cluster state, right? Which is a stateful component of the Elasticsearch cluster, right? So that state about the last execution, if successfully, is stored on the cluster state. So it's extremely resilient, right? So, oh, Ricardo, what happens is one of the nodes that was processing the transform fails. Actually, not much. The node will fail, and another one will be elected, right, by the master node, and then this other node will resume the process given in the last timestamp that was stored on the cluster state, given this information about the timestamp, right? And you can specify here on the delay, what is the amount of, we call this pushback, right? Okay, how much pushback behind you are going to reprocess in case you need to resume the process, right? Which is pretty awesome because the minimum is 1 second, right? You can actually, so that means that you conceptually can lose up to 1 second of data by the time you resume in another node. It doesn't mean that the resume processing is going to happen in 1 second. What it means is that by the time it resumes, right, you're going to lose 1 second of data, right? And this has to do with a bunch of other factors: how frequently the data is coming, how frequently your Elasticsearch cluster is indexing the data, so forth, right? So it's pretty cool. All right, so this is what I've basically done here with data streams and the scoreboard, right? There's another feature here that's very interesting as well. Well, I'm not sure how many of you know this, but Elasticsearch has different data tiers, right? Data tiers, I don't like the name data tiers at all, because it's not just about data, right? I like to call data types. Data types is a better name. So each Elasticsearch node, you can specify a role, right? So there has to be at least one master node and one data node, right? The master node is what we call a tiebreaker, right? Every time the consensus protocol of the Elasticsearch cluster needs to decide primaries and replicas and who's going to be the leader, who's going to be the follower, the master nodes or the tiebreaker is the node responsible for this, right? It has to be highly available. And you have the data nodes, which, as the name implies, it is the nodes that actually is going to store data, right? And today we have what we call the hot node, hot data, warm data, cold data, right? And a little bit more, I'm going to talk about the frozen data, right? Which is something it's currently coming, right? It is available, but is officially coming, right? So there's data nodes, there's the ingestion nodes. I think it's one of the most common use cases for Elasticsearch, specifically if you're streaming logs into Elasticsearch is, okay, I'm going to need a pipeline that will enhance or insert new fields or extract some fields or deduplicate some fields before the actual indexing part, right? So you can define what I call the index pipeline processor, and those processors and pipelines is going to be executed in one of the nodes from the ingestion nodes, right? Which is pretty awesome as well. And Elasticsearch allows you also to deploy machine learning jobs, right? Which is pretty cool as well. This is obviously, it is very data type sensitive. For example, it's not for, all right, do you need a machine learning node for every use case in Elasticsearch? No, it doesn't make any sense. But for use cases such as, for example, observability, right? It makes total sense, right? Oh, Ricardo, what do you mean by observability? So think about this. You have logs, metrics, and traces coming in and stored in Elasticsearch. And instead of having a human being look into the screen to check if there is some outliers or there is some trends about, all right, every Tuesday, our load has a peak, right? We can deploy machine learning jobs into Elasticsearch to keep observing for us, all right? So instead of actually kind of that's a way to reduce the human effort of monitoring and doing some proactive insights, right? Insights is all about putting a human being analyzing data, right? That's what data science does, right? But data science are known to also as well to be, okay, but it doesn't mean that we don't have to be efficient, right? We can put our insights in a form of a job, a machine learning job, and we can deploy this. And the beauty of deploying machine learning jobs along with your Elasticsearch cluster is because the data and the job will be co-located, right? I come from the big data world. So in the big data world, at least used to be like this, right? We used to have those Hadoop clusters where all the data sets would be stored, and we would have a separate cluster for the Spark jobs, where the Spark job will be the ones that are actually doing the mining and the processing. But I would need to have a Kafka in between my Hadoop and the Spark to keep transferring data from Hadoop to Spark, so Spark could actually have data to work with, right? And here, you don't have this problem because the data and the jobs are co-located, right? So that's the beauty of having machine learning nodes into your Elasticsearch cluster, right? So just to emphasize that this is possible. Again, it has to justify it, right? You're not going to create machine learning jobs for every single Elasticsearch deployment. It doesn't make any sense doing this, but there are use cases where this could pay itself off, right? Tomas, just make sure we are on the same page. We have roughly 10 minutes, right?
Generally have more. The full it's 2 hours, but yeah, just continue. I think it's fine because we have only one speaker per event, so you want to start here
gotcha.
today.
Okay. So in this case, all right, so good. Let me know if you have any questions. Let's take a pause. Let's breathe, right? Let's take a pause and let me know if you have any questions for what I've mentioned so far. So we discussed the Terraform provider, the data streams, transforms, and data tiers, right? For if there's any questions about any one of them, let's discuss. Otherwise, we can just continue, right? So you can put on the chat. There's something on the chat here. Oh, okay. So it's the probably people were inspecting the JavaScript code behind the browser. So that's okay, right? Cool. But yeah, let me know if you have any questions, right? So yeah, there's one here. Can we keep index setting in TF like a mapping? Yeah, exactly. So Terraform, okay, let me show you this real quick because this is, I understood your question, but the answer for it is more for the Terraform side than actually the Elasticsearch side. So let me show you here when I've deployed this on Google, right? Yes. Okay. So yeah, just as a note, yes. So you can do this, right? What I was about to show is because Terraform maintains state, right? So whatever you describe in the files, the state will be stored there. So that's how it works. All right, cool. Thank you. Any other questions about Terraform, data streams, transforms, right? It doesn't have to be a question. Do you like it? We'll have to see the whole 10-hour session about another question. Right, Philip? Right, that would be great. That would be great. This is something Tomas should organize, like a hackathon of, man, let's talk about Elasticsearch, 10 hours of Kafka, 10 hours of Pulsar. That would be great. DataCon, like it.
Yeah, and that's the way how the great ideas just born. So I will write it down and and it right on my to-do list.
Yeah, it's going to be exhausting. That's a given, but I think it's going to be cool. All right. Okay, so if there's no more question, let's continue. All right. We stop it on data tiers. And actually, the only reason why I brought data tiers, because it is a common terminology on Elasticsearch. Like people that work with Elasticsearch probably would know what this means, right? But what we are going to discuss later has to do with this. So that's why I put it here. Okay, so the next one is going to be what we call ILM, or Index Lifecycle Management, right? So Index Lifecycle Management, it was created for one specific purpose in mind, but it became so interesting as a feature that we further explored for other use cases as well. But I think the best way to explain ILM is to rediscuss what was the original purpose of what ILM was created. So let me go back for a second, right, into the data tier discussion, right? So I was showing you here on the data tiers that we have this kind of a persona called data nodes, right? So data nodes, it's where, like I said, is where the nodes of your clusters that's going to store the data. Yeah, that's kind of obvious, but you can specify what type of data you are going to store in a given node. And this itself, guys, sorry, I have this, like, terrible habit of keep the word guys because it's a jargon, but it's wrong. I am sorry for this, especially if you have some ladies in the room. I think what this is amazing about this, I like to call hybrid storage strategy for an Elasticsearch, because this is a problem that other distributed systems and other technologies are currently facing, and that Elasticsearch solve it, right? For example, for those of you that know Kafka, right, you might be familiar with the KIP 405, right? KIP 405 basically is a strategy to replace this behavior currently on Kafka, that each broker will store its data on its own data node or its own bunch of disks tied to that node, right? So what does that mean by this? Kafka has a serious problem of scalability, right? Because it's not economically viable to scale a Kafka cluster, right? Sometimes you are running out of storage on Kafka, but in order to increase your cluster and storage capacity, you have to increase your compute power, right? Because bringing a new node is not just a disk, right? You have to bring disk, memory, and CPU, which are expensive resources. It's not just put a new disk, right? Elasticsearch does this differently, and I would say smartly, right? Because you can effectively have different Elasticsearch nodes, each one with its own storage options. For example, I like to store hot data, right? And hot data, I can use a node with solid state disks, right? Which is pretty fast. However, for the warm data, I can have some mechanic disks instead of solid state disks, which is a bit cheaper, right? And for the cold data, I actually can have another strategies, right? Some other type of disk or other type of storage that doesn't have to be as fast and therefore doesn't have to be as expensive, right? So you have options to grow your Elasticsearch cluster economically, right? Which is pretty good. That's what I call a hybrid storage strategy, because it doesn't have to be religiously, oh, every single node has to be the same because the overall performance will be based on that. No, that's why you have the concept of roles, right? Elasticsearch knows that, okay, if that given node is supposed to have warm data, right? So the request should not like hit there immediately. You have to hit it first for the hot data, right? So anyway, you got the gist, right? With that said, right, I just set a context here. With that said, imagine what would you need to do in order to kind of keep moving the data from what is hot to what is cold or to what is warm, right? Before ILM, you would need to manually and programmatically set requests for, okay, I'm going to move data, re-index this data from this index to the another that's sitting on another node, right? And then you would have to keep doing this kind of a continuously, right? Because data will continuously coming in right now. So this is a never-ending exercise, and it takes time, it takes patience, and more importantly, is error-prone, right? You can fail, right? So ILMs is a way for you to programmatically and automatically, right, outsource this responsibility to the cluster, right? So by the time you create an ILM, all this data movement for cold, hot, and warm, and frozen is going to be handled automatically, right? But based on some criteria that you specify, right? In this demo that I've created here, I've used this actually. So if we go here to the index lifecycle policies, you're going to see that there's one here that I've created specifically for the data stream. All right. This is actually, by the way, this is actually mandatory for data streams. If you have an index, okay, you can optionally create a ILM, right? But if you are working with data streams that does this, right, active index, backing indexes, and blah blah blah, you have to use an ILM. So you were forced to. You have to specify. So that's one of the reasons why I use it here. But let me show you here this ILM for a second. So in an ILM, you have the phases, what we call phases, right? The hot phase, you have the warm phase, the cold phase, and the delete phase, right? The meaning of each phase is very simple, right? Hot phase, all the data that is currently being indexed and queried constantly. Warm phase data that is right is not so frequently updated, but from time to time there will be some requests, right? Code data that is definitely not updated or inserted anymore, and eventually you might need to query, right? Typically, like longer data for 6 months is 1 year, something like this, right? And as the name implies, delete, the delete phase is, okay, I am going to get rid of this data. I don't need this data in my Elasticsearch anymore, right? So as you can see here, each phase, or except for the hot phase, which is the mandatory one, each phase has a toggle, right? At least in the visual builder, right? I'm going to show you all of this here in a code in a second, right? But if you create here your ILM, you can toggle, okay, I need a warm phase. What is the criteria for the warm phase? All right, so I'm going to hold the data that is 30 days after the rollover from hot phase, right? So this is the criteria for the warm phase. What is the criteria for moving from the warm phase to the cold phase, or the warm data to the cold data? It's going to be any data that is lived after 90 days after the rollover, right? And I'm going to actually have some extra settings, which is I'm going to freeze that index after it runs on the code phase. So it's froze, right? You can like automatically instruct the clusters to freeze the index after it's done in this, right? And more importantly, let me put it here, actually in the warm phase, I did this. Yeah. The index that I'm using here has 2 shards, right? I created 2 shards because I have 2 nodes. But one of the criteria that I've set here for the warm phase is that, all right, if it goes to the warm phase, I'm going to decrease the number of replicas from 2 to 1, right? And I also want to shrink the number of primary shards to 1. So it's not only move the data, right? That's the part I've said before. Right? There was the original intention, the ILM, and then they start building some more extra functionalities. But you can actually execute actions, right, along with the data movement, right, which is pretty cool because it will be part of your data cleansing process that you would have in the company, right? So this is the visual builder, at least. Let me show you the code that I've used to create that. Scripts. So that's the data stream policy, which is basically what I show you. Let me close it here so you have more space. Let me close it here. So this is what the ILM policy looks like in a code form. So you basically create a policy, you specify the phases, and then we have hot, warm, cold, and delete, right? Except, as I mentioned before, except for the hot phase, all the other ones are optional, right? If you don't put a warm here, there will be any warm, and therefore there will be any other. The only thing, if I remember correctly, the only thing you cannot do is to move data straight from hot to cold. You have to pass through warm, right? So there's a phasing in place, right? But all the rules and actions are specified here. So you can see here that the mean age is the criteria that I've used it. But along with the criteria, you can execute a sequence of actions, right? Yeah, so there's some questions in the chat from Adrian. Yeah, so Tomas just responded. Sorry, let's keep going. Okay, good. Oh no, there's a question here. So we are not able to remove warm and delete to stay with hot codes. No, yes, actually you have. You are able to. You are able to. What I said, okay, what I said is that if you don't specify the warm, right? So when you deploy this, obviously there will be no warm phase. So ILM is not a complete sequence of phases that you have to use all of them, right? You can selectively enable each one of them. But yeah, you can have only a hot code architecture. Yep. But that's the tricky part. Like if you combine, and this is only a recommendation, of course, if you combine the power of, okay, you have a hot and cold, but what if you have data that is so old that you want to offload from your hot and cold, and you can put this on the frozen tier, right? Using, for example, instead of using disks, you can use block storage, right? So not only you make your Elasticsearch more cheaper to maintain, but also you offload some data, right? So it all comes down to make your Elasticsearch respond faster for what matters, right? Which is pretty cool if you think about it. It is possible to move to S3 of Google storage. Yes, it is, right? It is actually what I'm going to say in a second, but yes, it is possible, right? No, that's okay. That's okay. My logic of sequence here is not so intuitive. So yeah, that makes sense, your question. All right, let's talk about the other one. There's something called API keys, right? In a minute, I'm going to talk about S3 and Google Storage, but there's also something called API keys, right? API keys is something that's not so intuitive to use, mainly because I don't think this is a very established and concrete practice in the industry itself, right? So at least I grew up writing applications using Delphi, right? So in Delphi, I would create an application, and if the application needs to store data on Interbase or Oracle, I would create a username and password in my database, and I would like hard code this username and password in my application, right? So for some reason, we grew a community of developers that has this mindset of how to interact with specific technologies using username and password, right? And there's nothing wrong with this, right? Technically speaking, all right, this is wrong. No, it's not wrong. It's just not scalable, right? The word here is about scalability, right? So by the time we start having this concept of, right, applications now are being deployed in containers, and you can spin up containers and functions, right, on demand all the time. And before, in the old client-server architecture days, we used to have like 20, 30, okay, let's give it 100 applications connected to your Elasticsearch. So yeah, okay, I think it's okay to create 100 username and password for each applications. But now, what if you have hundreds of millions of thousands of applications connected to Elasticsearch? You're not going to create a username and password for each one of them. You could, but you shouldn't, right? So that's why we have API keys in Elasticsearch. And this is something that people don't explore too much, at least in my opinion, right? But you can use it. That's the beauty of it. For example, I've used it here in this demo. And if you go here to the secured session, if you go to users, obviously you're going to see that anonymous user that was created automatically by Elastic Cloud, because this is a deployment for an Elastic Cloud. So yeah, the user will be there. But if you click here, also under security, there will be something called API keys, right? And I have an API key, right? So the API key, it works like it is a credential. And just like username and password, it can have roles associated with that API key, which means that you can fully control the RBAC, right? Role-based access control lists of given indexes, index patterns. So everything can have the same security control granularity that you would have for username and password, but with API keys, right? How do you create an API key? I have an example here, actually. Basically, you post this security API key, and then you are going to set the expiration. This is something pretty cool, because imagine that one of the main security vulnerabilities for Elasticsearch, not only Elasticsearch, for any technology, any data store, is that sometimes we create a username, and if the application retires or it no longer exists, we forget to go there back and, okay, I need to retire this username and password, right? Some people do, some people don't, right? Most of them don't. And that's why we have some vulnerabilities, because you can create exploits that look for available username and passwords to use. The point is, with API keys, you can set expirations. Why this is important? Because perhaps you are going to spin up a new container on AWS, right? Using ECS, for example, and this container is going to be short-lived. This container is going to run for 30 minutes just to run a machine learning job or some processing, some ETL processing that will read and write from Elasticsearch. So you can set, all right, this API key is only useful for, not 30 minutes is the maximum, but 45 minutes, right? After 45 minutes, if you try to issue a request with this API key, it will not execute. You're going to have a 401, right? Which is, right, not authenticated, right? So, which is pretty cool. And you still can specify the roles for each clusters. You can specify for all clusters. The granularity is very interesting as well. You can specify for clusters, indexes, index patterns, and all of this. And then you're going to receive this, the API key itself, right? For you to formulate a request that is going to use that API key, actually, I forgot how to use the API key. And that's why it's always cool to look back to the code, because I did this in the code. I just forgot. So let me recap what I did here. So all of this is written in TerraForm. So let me take a look what I actually did. Images, JavaScript. All right, here we go. So I create this template for API key JSON, right? Which is basically is this file over here. This is my template for the API key. Okay, so there's this. And then I am going to execute this script over here, API key sh, right? And I'm gonna pass as environment variables some information about my Elasticsearch cluster that was created programmatically using Terraform, which is the endpoint, the username and password. And this is going to be my request that I've shown you before, right? So basically what the script does, let me show the script. Where's the script? Script. Basically what the script does is to issue a post using that JSON, and it's going to retrieve the ID and API key. So this is what I will try to remember. So as a response, I'm going to grab the API key ID and key, okay? And oh, here we go. So what you need to do for your applications to use the API key is this. Your authorization header that you have to include in your applications needs to start with a prefix API key, space, and then you're gonna need to encode in basic64 your API ID, column, and then you provide your API key. So this is how you are going to put your applications to use an API key. So there is this convention that's almost an industry standard, right? But if you don't know how to use it, it can be a little complicated, right? But this is the format that you can use for API key. So there's this. I think API keys are quite powerful for you to almost kind of offload your concerns about authentication and authorization in an application level, right? And ultimately, it makes sense because each application is an application, not a human being. So why creating username and password for applications, right? They're not human beings, right? So any questions related to API keys before we move forward? Nope. Okay. All right. So let's continue. And then we have this thing that started and was announced officially on version 7.11 of Elasticsearch. It's called schema on reads. Actually, the actual feature is called runtime fields, right? Schema on reads is more the use case that you can use along with your Elasticsearch cluster. So what this does is something that I think every database user or database developer is like this very much, because let's face it, one of the most source of struggles for people that actually work with data, especially users, right, is they're trying to do their data analysis there on Kibana, for example, and then okay, in order for me to actually implement this analysis, I need a new field, right? But what needs to happen is that, all right, so they need to tell the whole application development chain and the DataOps chain to include that field so they can continue their work. So there's a process in place that's not necessarily very fast, right? Most of the time it takes a long time. So the application developer or maybe the person that is ingesting the data has to include that field. Perhaps it's that information is coming from a Kafka that another team is responsible for. And most importantly, there's Elasticsearch where you can, okay, there's some new field. So you have to change the mapping, right? You know that everything in Elasticsearch is immutable, right? So there's no such thing of changing the mapping on the fly. So what you have to do is to create a new index with a new mapping, with a new field, and migrate the data, right? Or create an alias that will look like, that will point into. It is a very manual effort that ultimately, the problem is the data analyst guy on the Kibana side that is waiting for hours, days, weeks, perhaps even months for the new field to arrive so they can continue their work, right? So with schema on read, they actually can have this capability of adding dynamic fields to a given mapping for a given index, right? What is cool about index runtime fields is that, as the name implies, those fields are not starred, right? So let's say in this example over here, I have, let's say I have this schema here, the mapping, that only two attributes, name and social security. However, my use case as a data analyst requires me to have information for the age itself. I can include that age dynamically on an Elasticsearch level, and my Kibana users can simply use it. The only difference is that this field age is going to be computed dynamically on read. Every time they issue a request to the index, the response will come with the new field, but there is some increase in performance, the CPU overhead for this to happen, right? So it's a trade-off about, okay, there's no storage, there's no IO, there's no disk IO, but there is some increase in CPU. No, it's not much, like, oh, it's going to be twice, three times the size. No, it's not much. But at scale, this can be significant, right? It is ideal for you to evolve your data analysis as fast as you think, right? Because this is how data analyst works, right? But it doesn't replace the fact that, all right, by the time the data analysts say, okay, I'm done with my work, this is the data schema that I need for me to implement this, and then the developers still have the responsibility of grab that and create the actual mapping, right? That will be specified on the index level for the real application and production, right? This, I would say that runtime fields cannot be like your permanent solution for evolving a schema. I think there's still value for you. Okay, if semantically a new field is belong to your domain data model, right? It needs to be part of your mapping, right? Because someone decided that makes sense, right? But as a patch up, as a band-aid, right, and to make it things faster, runtime fields might be a lifesaver, right? So there's this. So runtime fields. I'm going to make available this presentation later, right? Along with the recording that Tomas will be made available as well. So for each slide, I put here the link on the documentation, right? As you may know, the Elastic documentation is pretty amazing and complete, right? So reading it's one of the few documentations that you actually learn something, right? It's not confusing at all. It's actually helpful. So if you want to understand more, it's, Philip, I agree with you. Like I've worked with in some companies that documentation was more troublesome and confusing than the actual, right? Sometimes it was better to read the code instead of the documentation. So Elastic is good at this. But what I was saying is that if you want to learn more about each one of these features, just grab the link here. It will be ready to go. Yes, Java is not very good. Yeah, I agree with you. Yeah, it's not very intuitive at all. All right, let's talk about searchable snapshots, and then we're going to go back to the question from our friend Dudek that asked about if it's possible to move data from S3 or Google Store. So there are two features, right, that Elasticsearch leverages those object stores, right? But let's talk about searchable snapshots. The other one is called frozen tier, right? Frozen tier, it's something that it was announced, okay? Just a disclaimer. It was announced But if you try to download Elasticsearch right now, it won't be there, right? It's coming on the 7.12 release, okay? But you can read tons about it, about what's going to be the idea, how it works, right? It's the information itself, it's available, right? But let's talk about searchable snapshots first, because there is some confusion in the community about, all right, so frontier is the same of searchable snapshots. So, and it isn't. It isn't, and that's why I decided to bring here those two, because they seem to be used interchangeably, but that will be a mistake. So if we go back to the concept of data tiers, let's recap. You can have data nodes for hot data, warm data, and cold data. All right, this is done. Oh, I have hot, cold, warm, and cold, right? And it would make sense, okay, in the cold data, in the cold layer, to store data on object store. It would make sense. And technically, right, it is possible, right? You can tweak and outsource the storage part to a object store. Actually, you can store in pretty much anything, right? Because this is all going to be about mounting devices and the operating systems that Elasticsearch node will run. So this is not about technically possible or not. It's more about making sense or not, all right? So what is code data, right? Code data, as we explained before, is data that is not frequently accessed, right? But also, more importantly, it is data whose level of reliability or durability doesn't have to be so strong, right? So searchable snapshots is more like a feature to address this concern. So let me explain this in a more appropriate way. When you have an index that holds hot and warm data, you have the concern about durability. What is durability, right? So it is making sure, for example, if you have 2 shards or 3 shards or how many shards you want it, each shard will have replicas on the network, right? Why you have replicas on the network? Because it is cheaper in the case of a node fail to recover all your data from a replicated shard instead of going back to the disk, right? This is why you have durability in a network level, right? This is part actually of a distributed system concept, right? So there's this, right? So every shard has replicas. So, but you know that replicas in Elasticsearch, actually in any distributed system, doesn't come for free, right? For example, if you have a document with 5 documents, right? And these 5 documents are stored in a shard. So let's say these 5 documents are worthy, 10 documents are worthy, I don't know, 10 megabytes, 1 megabyte per document, right? Pragmatically speaking, if that shard has a replica, you would actually be storing 20 megabytes, not necessarily in the same node, in the same shard, but in an overall cluster, right? So you are always doubling or tripling your data size depending on the amount of replicas that you have, right? And this is exponential, right? Because replicas are tied to shards and shards are tied to indexes, right? So what I'm trying to say is that it's not cheap to apply durability in your Elastic cluster, right? However, like I mentioned before, if you have data that is code, and code data doesn't make any sense have to be so paranoid with durability, right? Because, all right, yeah, it failed, but okay, the data is frozen, right? So I can like allow myself to wait a little bit, right? To recover this from some external storage, bring back to the cluster, and then serve the request, right? This is what searchable snapshots are about, right? Is a way for you, okay, instead of storing the replica shards in your cluster itself, in other words, in the disks of the cluster of your Elasticsearch, you can put this on the replicas. That's the important part. You can put the replicas on S3, on Google Cloud Storage, or Microsoft Azure Storage, right? Which are cheaper durability options, right? Yes, there will be a little bit of a penalty in performance because there's no magic, right? It will incur in a network round trip to recover in case the replica is not found primarily. But by the time it's found and it's brought back to life into the cluster, the second and the third request will be extremely faster, right? So this is an implementation that Elasticsearch did on 7.11 that it was both an implementation and upgrade they did in Elasticsearch level and Apache Lucene level to like rethink the way caches work to afford this use case over here. It is pretty awesome if you think about it, because you can reduce the footprint of your Elasticsearch cluster in terms of durability by offloading replicas into snapshots that are on S3 and object storage, right? So it again goes back to the concept of, all right, it is economically cheaper to grow your Elasticsearch cluster, right? That's why I think it is an amazing technology, because it provides you options to handle distributed system problems, right? All right, but this is searchable snapshots. So just to summarize, what is searchable snapshots is for you to offload shard replicas, right? It's not the primary shard, it's the replica shard to S3 or object store, right? So this is usually for the code layer. However, what if you want to effectively store all your data on S3, right? And or any other object store. S3 is just an example. It can be Microsoft or GCP or any other, right? This is why we are creating the frozen tier, right? The frozen tier is going to be a way for you to mount a snapshot that in turn is available in the object storage, but all the data is going to be served from there, right? Which is pretty awesome. So now, what is the difference? We're not talking about the shards replicas. It's your primary shards that's going to be stored on the object store. So yes, obviously, right? If you make a search or issue a request in the Elasticsearch that fails in the data that is in the frozen tier, it's going to be slower than when compared to actual disk, right? But the whole point of the frozen tier is about this. That's why you have the magnifying glasses here. It is about money, right? What is the problem that you're trying to solve here by leveraging frozen tier? You want to make sure that your Elasticsearch cluster can grow, right, economically viable, right? So, but now you have options. You have full data stored on a tier, which is the frozen tier, right? Or you can have only your replicas on the object store, but your primary shards are still in the high-performing disks, right? So you can mix and match the options, which is pretty awesome. I think when you have a technology that provides you options, that's what is great about it, right? When it's too rigid, when it's too restrict, you end up with your hands tied, and you oftentimes start complaining about the non-availability of the options, right? Any questions about this before we have one last feature, and then I'm gonna wrap it up. But regarding these concepts of snapshots or data tiers that we have discussed so far, any questions so far? Nope. Okay. All right. So cool. So let's talk about the last one. Not the frozen tier. I put a comment here. Sorry, there's no URL for this one because, as I mentioned before, there's no, it hasn't been released yet. It's coming on 7.12, which is, I can promise dates, but trust me, it's sooner than you think, right? Technically, it's available, right? The code is GA already, right? So it's only a matter of integrate with the rest of the Elastic Stack. So the last feature I would like to discuss here, it's something that I actually, it's funny because I actually had to use this. I created a demonstration a while ago, and one of the purposes that I would like to demonstrate is the usage of emojis as part of text, right? Because this is getting common these days, right? Just like if you think about the title of the presentation, I put it, I didn't know that Elasticsearch could do that. And this is not an image, this is an emoji, which is a character, right? There is some Unicode character behind this, right? It's only your screen that's translating this into something useful. But the point is, Elasticsearch by itself don't know this, right? So imagine that you were trying to search for things in a text, right? And perhaps you were trying to deal with emojis, right? And now with this concept of mapping character filters, it is a filter in the end of the day, right? You can specify a filter, which is a mapping of mappings, right? The type is called mapping, and you specify kind of a key value of, all right, this is the character, and this is what's going to be the equivalent. This is the character. This is going to be the equivalent. So by the time you apply this filter into a text, and it has this mapping character filter enabled, it's going to do this. Okay, if it finds that character, it's going to replace for the value associated with that key. That can be anything, right? That can be a whole complete text. It doesn't have to be only one character, right? So this is amazing because sometimes there are some languages, I forgot this on the top of my head right now, but there are some languages, actual human being languages, like Spanish, Portuguese, English, and blah, blah, blah. But there are some other languages that as part of the language, they use the special characters, right? That's not just punctuation or accentuation, right? It's more like special characters and their meaning. So if you ever have to do with those languages, or like my use case, I had to use emojis as part of my text as well. I think using the mapping character filter is a nice way out, right? Is a way for you to transparently translate things without necessarily to impact your mapping, your actual mapping of your data model, right? So filters are very powerful for this in Elasticsearch, all right? All right, so I know that this has been a little bit of a lot, and to digest at least. It's not very simple, but I think what is important for this presentation from today is for you to, okay, you came up with ideas, right? You know, like I mentioned in the beginning, knowing what's possible sometimes is more important than knowing how to do, right? Because knowing how to do, you go here, click on the URL, documentation is awesome, read it, you're good, right? But sometimes not knowing what is possible is the major problem. So thank you for your time. I know that might be a little late for you right now, and that's one of the reasons why I appreciate a lot people that gave up their time with their families that they could be spending with them, that they're here to learn. So thank you very much for this. And Tomas, once again, my man, thank you for the opportunity.